So 332 is where we're going to try to talk through this stuff. So from 1 to 6, you were just plugging in these numbers, you were seeing if they work. Predominantly, were you saying yes, or predominantly you were saying no, or was it about 50-50? How did you feel like it shaped up?
More yes.
Way more yes. Not a lot of no's. Did anybody find any no's? 2 is both yeses. Anybody find any no's? 3, first part or second part, or both?
First part.
First part of 3 is one of our no's.
Oh, I thought you meant how many.
Okay. Yeah, there are 2 no's. That's one of them.
And then
4, first part or second part? First part of 4. First part of 3, first part of 4. That's your only no's. Everything else is a yes. If you didn't get that, like, just check your foiling, probably check your signs, because that's probably what might have gone wrong. Anybody need guidance on 1 to 6? Okay, so 7, you'd have written yourself an equation. All of these equations, to be equations, to meet that title, what do you have to have to make the title of the equation? Equals. We got to equal something, and they all, in this case, equal 0. So what you would have done on 7 is just write x minus 5i in parentheses, x plus 5i in parentheses, let it equal 0, and move on with your day. If that were an even question, though, I would have instead asked you to also distribute or FOIL or do whatever you had to do to multiply that out. 8 will be x squared something with a 49 to equal 0. Plus or minus? Plus, I think. When you go to do something like 9, make sure you go and change all of the signs of what's written in the book. So every set of parentheses starts with an x. Then what would be the signs on the 1 and the I for the first part of 9? Minuses both. You'd go x minus the 1 minus the I. Then the next group, you'd go x also minus a 1, but plus an I this time. That'll be a little bit of a foiling extravaganza. If 3, well, we aren't foiling that one out, so I guess it doesn't matter. But if you were foiling that out, 3 items times 3 items, temporarily, 9, and then it'll whittle down a little bit. But that's the kind of thing you're doing 7 to 18. Does anybody need guidance on 7 to 18? Or me to do an example problem or anything from any of them? 19 to 26, you're solving for x. So that was probably the most challenging part of this homework. You're going to have to do a bunch of distributing at the beginning to get rid of all the parentheses. Then you're going to have to do what? After you get all your distributing done, get all the x's to one side, and either while you do that or right afterwards, get all the other stuff to the other side. You probably have a couple of x's at that point, probably 2 of them, and we need 1 of them. So how do we make that step? Take out a GCF, and then you're going to divide. And when you divide, that becomes a whole process in and of itself. The odd answers are in the back, so if you check your odd answers in the back and you're getting them right, you're probably good on the even ones. If you're getting the odd ones wrong, then maybe I need to do one of these for you. Is there anybody that has a 19 to 26 hang up? 21 hang up? And so 21, I've got a 2ix plus a 5 minus a 4i equals, distribute 2x plus 3ix minus 2i. Good on that. So 2ix, does it have any friends to change it? 3ix. If we get that positive, subtract it over there, I'd get
Negative 1ix.
negative 1ix.
I thought we were wrong.
Okay, we'll keep going, just that might help somebody. Anybody else going leftward? 2x, sign on the 2x, minus. Everybody else go rightward, so is this changing or keeping? Changing because of that, 2i. This has to move, -5, so that stuff all went right, the other stuff all went left. We sit here, anybody mad at that? Okay, then what did we just say a couple minutes ago, has to happen toward the end, I think of all of them, if not most of them. GCF, so x comes out, -1i minus 2 equals this. To get the x, you're always going to have to divide. So that's going to stay on the top. -1i minus 2 is on the bottom. And like I said yesterday on the quiz tests, whatever, that's a 2-point question. If you can get to here, I'll give you a point because you earned it. You did some good stuff there. Question getting to there. And why is math a little bit grouchy at you still? Can't have i's on the bottom. So we're going to multiply the conjugate, which means to change the sign with the I. So +1i, but still a -2. +1i, a -2. The bottom is not hard because we have a shortcut that's going to take us square add, 2 quick steps. 1 matters, 2 matters, square add, 5. Question about bottom shortcut. Top's a FOIL, so what's a thing from the top? 2i squared, which is better as
-2.
Another thing up there, a -4i, which is going to have a friend, -5i, together make -9i. Who else is up there? +10. And we're close. Question about that? You need that, right? Can you grab me that other one? Whittle this down a smidge. We're better to erase the 2 and 10 and leave an 8. And if you get to that point, I think I just give you your full 2 points. I'm pretty happy with that answer, but I'd still make you fix this because the math community generally makes you want to write 2 fractions where the second fraction has the I. So first standalone non-I fraction, 8/5, and then the other fraction, go -9/5. And if you could, you would reduce those. Here we can.
Yeah.
Anybody not good on that whole process of what was up with those? Then 27, 28, you just FOIL it, show a little bit of work, and it should make the last thing they typed in the problem. 29, 30, you just take the stuff times itself, FOIL it out. It should make the last part of what they said in the problem. And then how did we decide to find the other roots? Switch the signs. Some of them or all of them? All of them. Just switch all the signs. That's 332, quick overview. Anybody need more than that from a 332 medium length overview? What you got?
Can you do number 3?
Number 3. Okay. I'll let you get there. 332 is what it is. So for number 3, we need that root and the 2 and the I to get plugged in for x and get squared. So if the root 2 gets squared, that's a regular 2. When the I gets squared, that's -1, and that turns our 2 into a -2. And if -2 is trying to add 3, no, that's not equal to 0.
Okay.
You with that?
I think.
Then if we try on the negative root 3i thing, and we put that in where the x is, and everything gets squared, the negative squared becomes a positive. Root 3 squared becomes
A negative?
regular 3.
Oh, okay.
The I, when it gets squared, switches the sign, because that's -1, to make a -3. You with that? Or rewind?
Yeah, I think.
And then if -3 adds 3, it equals 0. You say yes then.
Okay. I think I didn't really know how to do that section, but I think I know what I was doing wrong in general.
Okay. You say something?
I was gonna ask.
Same one. You with that, what I said?
Yeah.
Do something. Number 3? Is that what you're saying?
I would like change it to the other square root.
Oh, the other square root, you just switch all the signs. Just switch every sign of what they gave you. So like, if they said 3i plus 6 is a square root, you could make it negative and minus. You switch all the signs.
Okay, so how do you do like 27 and 28?
27, you just FOIL it,
Okay.
and don't do the two-step shortcut plan, because you wouldn't have anything to show. Like, do it actually foiling to show the 4 items, and it should like eliminate down to the stuff after the word of. If you FOIL the parentheses stuff, it should make the back half of the problem.
Alright.
Sure. Anybody else? 332, question about how to do any of those skills. Anything that's done, send it down, fix some quizzes, old homework, new homework, whatever homework, completed stuff, down it goes. I'm going to skip 710. 710 I've not ever seen come up in my career of teaching classes, taking classes, SATs, PSATs. I've just never seen this come up. So I'm going to skip that. If you ever go anywhere in your life and they ask you to graph imaginary numbers, or they ask you to do absolute values of imaginary numbers, then I guess come back and tell me about it, and I'll start teaching that lesson again. But I don't think that's going to matter to anybody. So 711 is where we'll go, not to the convenience store to buy a Slurpee, but to Chapter 7, Section 11. There's just some facts about conjugates in this section. This wraps up our chapter. Tomorrow we'll have a homework due. We're also going to have due the first sheet, the practice quiz from 7.6 to 7.11. We're going to do both of that for tomorrow. And for a second you think I'm crazy, but I'm not. You'll see. Tomorrow on this calendar is Wednesday. So Thursday we would take a quiz that's like the littler sheet I gave you. Friday the stapled packet would be due. So if you want to get a head start, you could. It's there. Friday we would do a review for the chapter. Monday we would take a test on the chapter. Question about schedule. Okay. So first thing they do is just decide to make some symbols for things. So complex numbers we talked about a few days ago. What was different between a complex number versus an imaginary?
Complex is like that A plus BI.
Yeah, it had one part that was.
So
Complex is just the number and then the imaginary.
Yeah, it had an imaginary part and it had a real part in the same number. So if we have a real thing plus an I kind of imaginary thing, you put it together, that's called a complex number. So at this point in the chapter, they're tired of writing them like this. And so they decide for a section, instead of having a name like this, they're just going to call all of these complex numbers Z. Okay, so that represents, there is a real part, there is an imaginary part. They don't feel like writing it in 2 parts anymore, so they're just going to write a Z. You've seen lots of Z's in your life. None of those have ever had anything to do with complex numbers. You'll see a lot of future Z's in your life. Almost none of them have to do with complex numbers. But for today, when you see one of these, you look around the board, you see a lot of Z's. Every Z on the board today represents a complex number. It has a real part, it has an imaginary part. So then they decide, instead of using the word conjugate all the time, let's make a punctuation up for that. So the conjugate of this thing that they're calling Z, they're going to call it Z also, but put a little line on top of it. Just quicker to do that than use the word conjugate all the time. Math fact that doesn't affect your homework life. If you take a complex number and you multiply by its conjugate, that always turns up a real number. Because what did the Z represent? Z is just a shortcut instead of writing A plus BI. The conjugate, the Z with the little hat on it, what's that represented in the bigger world? A minus BI. If we take 2 things like that and you multiply them, how does that turn up a real number again? What would that answer be if we tried to multiply those?
A squared minus B squared Y squared.
Okay, in other words, A squared plus B squared. We could do that by FOILing it out, or we have that
Square
square it. So A gets squared, B gets squared, we add it. It's also just a fact that doesn't affect your homework life. If you have a complex number and add its conjugate, that always turns up as a real. Because if we take this and add that, how does that turn up as a real? Why is the imaginary part not there anymore? Why is this a real number?
They cancel out
Who cancels out?
the B.
The adding BI and the subtracting BI would eliminate, you would just get 2A. So some of the moral of that story is, just because you temporarily enter imaginary number land, or you temporarily enter complex number land, you're not stuck there forever. You have some outs. Sometimes multiplying gets you out, sometimes adding gets you out, a lot of things can get you out. Okay, but complex numbers, they have an imaginary part, they have a real part, and they invented some punctuation to just describe those numbers and their conjugates in a shorter way. Question about that? And here's 4 ideas from the homework. So we've seen several things this year that are like this and just explained in math symbols, and then I give it to you in words. What this rule is telling you, if you were going to add 2 complex numbers first and then do the conjugate, you get the same result as if you did the conjugates first and then added them later. That's what that's telling you. What is this one telling you then? You could either multiply first and then do conjugate, or you could do conjugates first and then multiply. This is telling you that you could either do the exponent first and then conjugate, or conjugate first and then exponent. Our book is going to consider all of these to be simpler. For the same reason that bars problems sometimes were considered simpler, how did we simplify the absolute value problems in our past? Like if I gave you this, that wasn't the simplest way to do it. What was considered simpler than that?
You just put the X in, right? Just the X in bars?
We could go just an X in bars.
8 outside non-bars?
8 could come out.
X to the 8.
X to the 8 could come out. Why did the math community feel more proud of this? Why were they happier about this than that? There's less stuff in bars. This they're going to be happier about because there's less stuff under those hats. Okay, so they're considering that progress. The fourth rule we have, if I give you a real number, what was the conjugate of a real number back a couple days ago? I did one of these. Like I said, 4 plus 3i, and you gave me back
4 minus
4 minus 3i. If I gave you just the 3i, you give me back just a negative 3i. What if I gave you just the 4?
Nothing.
You gave me just back a 4. So if you get a real number, the conjugate of it is just itself, that number. So that's our 4 rules of the day. Question about the 4 ideas? So the homework will say this: find a polynomial using these z's with these hats on them, meaning conjugates, that is the conjugate of this original thing. So you could say, I'm trying to do the conjugate of that whole mess. And the book and math is a little grouchy with you because there's more stuff under there than needs to be. So we could use this adding rule to split this up into a couple chunks. A 3z squared, a 2z, and a 1. That's fair. Okay. The adding rule says, you can chunk these. So chunk, chunk, chunk. Question about that? We can. So the multiply rule says we can pull some more stuff apart. We could go 3 on its own, z squared on its own. You could do 2 on its own. You could do z on its own. You could do 1 on its own. The second rule, that multiply rule, tells you you can pull them all apart as pieces like that. something there. The powers rule tells you you don't need the power to be located
With the
under the bar. You can pull that out. So this could be a 3, a z with a square, a 2, a z, a 1. There's lots of little pieces. And then the final rule says if the number you have is a real, you don't need the bar at all. So we don't need the bar on the 3. You don't need it on the 2. And you don't need it on the 1. And that would be a correct answer. That's a longer way around the mountain than we need to go if you do one of these again. Everything I said is true, but I've been having a little bit of fun with you. Want a quicker way to do this?
Yep.
Instant replay?
Oh wait, no, not
This is-
instant replay. Just
It's the same problem. You ready? Done. You want me to do another one? So the book gives you this, and you want to do the conjugate? Ready? Done. It's going to take you 5 seconds. Yeah. Do one more if you're not believing me. You know, they gave you this. Done.
It's pretty hard.
Yeah, it's rough. That's why tomorrow we're doing a page,
My hands might
1 to
break.
10, and we're just doing the sheet. Because really what you're doing
Oh my God, Joe, I'm gonna do
is
this
the
one.
sheet. This is the greatest homework in the history.
I'm gonna do it, Joe.
One more time. I mean, this is a big boy. Ready?
Oh,
Big
boy.
one. Look out.
Aubrey, hold my hand.
Boom,
Okay,
done.
we made it.
Just put a line on every Z. At the end of the answer, the lines only cover the Z's and nothing else. If you've been through geometry, there's a question in geometry that makes like the final that you probably didn't even understand what it was. It asked something like when we did those silly questions, what's the complex conjugate of Z? And you went like that on it. You didn't really understand what you were even doing. I just told you, just do it for now. You'll understand in Algebra 2. Because half the class had seen that and half hadn't, and half of them think it's funny and half they're clueless.
Yep.
But just put lines just on the Z's and we're good. I once had a person who missed all of these on the quiz,
Oh,
and they missed all of these on the test.
oh.
They slept through the first lesson, and then they apparently just daydreamed their way through all of the reviews, and I just was astounded that a person could go 0 for 10 on a quiz and a test
That's
with
impressive.
5 of those. It was. That's true devotion to their nap and their laziness. That's
Wait.
tough to do.
Well, I mean, I kind of did.
Occasionally, I've had people miss one just by being careless because, like,
I'm gonna do it.
Yeah,
you know, you go like that, I'm gonna mark that wrong because the bar
We
shouldn't
just share it.
Be
like,
over
split it.
be over the 8. Just wanna hit the Z's. I've also had some people sometimes that will like skip one. You know, just don't be careless on that because that's unnecessary. But where we are with homework from this life, I would highly encourage you, just do this homework now and turn it in before you can lose it or forget it or whatever. But 338, there's a 1 to 10. So 338, 1 to 10, all you have to do is copy those 10 problems and put lines on the Z's that weren't there. When you go to do the quiz or test, I don't even care if you recopy them to the blank. If you just want to use the one I typed and just draw the lines, I'm fine with that. Save yourself a little bit of bother. I'm trying to give you a waste of 3 points on these, but that's up to you. If you want to recopy them, recopy them. But 338, 1 to 10, I'd say turn that in before you leave, and then it's just done. Then the main deal for tomorrow is the practice quiz, 7, 6 to 11, which if you're honest, you probably thought at first I was crazy giving you double homework.
I was a little
Just
A
astonished.
little bit worried about
Just a
that.
little.
But now you see that that wasn't really that bad.
So 1 to 10.
1 to 10 on 338 that's worth a homework grade for you, which is the easiest homework grade you'll ever have, probably in anything ever.
Do you need to show our work?
Yeah, make sure you show your work. The next sheet tomorrow, and then we review. Questions, anything?